Thanks, Adam. Good morning, everyone, or good afternoon, everyone, and welcome to today's session. My name is Mary Sy from Enbridge Gas, and I'm the Energy Advisor for a Commercial New Construction Savings by Design program. For those who are not familiar with our program, Savings by Design, it's an Enbridge program that is facilitated by Sustainable Buildings Canada that helps builders, developers achieve 15% energy efficiency above current building code. One of the methods utilized to obtain this and measure is through energy modeling. I'd like to introduce Alexandra from Pratis, who will be representing Sustainable Buildings Canada, who will be conducting today's webinar. Following the webinar today, a link will be sent out on how to access the information that is presented. Also, we'd love to hear from you as we'll be doing a live Q&A after the webinar, so please hold on any questions until then. The webinar today will also be circulated, so don't worry if there's a few things you may have missed. You'll have another chance to review the content. Thanks again for joining today, and I'll hand it over to Alexandra to begin.
Hi, everyone. Pleasure to be here. I think we just go right into the webinar here. Adam, is that right?
That's right. Here we go.
Hello, everyone. My name is Alexandra Onisco, and I'm a principal with Pratis Group, which is a full-service sustainability and energy modeling firm based in Toronto. And I'll be presenting about energy modeling, what it is, why we do it, and what are the benefits. Energy modeling is the process of virtualizing or computerizing a whole building, including the complete set of complex systems which make it up, such as the heating, ventilation, air conditioning system, the lighting systems, the building envelope systems, and so on. Then this virtualized model of the building or group of buildings is then simulated to operate for a year or a smaller period of time, if that's what's desired, using the location appropriate weather information to provide results or outputs. These outputs can represent numerous data points, but generally will provide information on the energy consumption, the carbon emissions, the utility costs, as well as the loads of the particular building that we are modeling. You cannot measure these things, you cannot optimize them, and modeling is used as the tool which then can provide us with those metrics. Using energy modeling, we can evaluate if the building that is being designed is in fact energy efficient, how energy efficient is it, how much the utility costs will be on a particular year, what the greenhouse gas emissions associated with us operating that building will be, and so on. Energy modeling allows us to see where the energy is being used in the building. For example, is most of the energy being used for building heating? Is it being used for building hot water? Is the lighting energy a large portion of the energy pie, and so on? So once we know where the energy is being used, we can focus on those areas and then reduce it. Energy modeling can also be used to reach specific targets for your building, whether those targets are mandated by an outside party, such as a municipality, provincial code, perhaps a agreement in the PSOS if it's a P3 project, or maybe it's a part of our corporate mandate. You can use energy modeling to see if you are meeting those targets, whether those targets are energy use intensity, emissions targets, energy cost targets, and so on. A Very important use of energy modeling is also compliance. So when we talk about compliance, most of it is with certain codes and standards, such as the provincial energy codes or national energy codes, as well as compliance with LEED standards. Speaking of LEEDs, another use of energy modeling is also for third-party rating systems, such as LEED, the Zero Carbon Building Standard, Green Globes. All of these standards have a significant portion of their accreditation attributed to improving energy efficiency, which is typically demonstrated through a building energy simulation or an energy model. And lastly, but not the least of these applications, is of course incentives. So Enbridge Savings by Design program is an example of this incentive stream where modeling is used. It is also used for incentives under the IESO for Toronto Green Standard Tier 2, which is a voluntary standard and provides development charge rebates. Other municipalities also have their own incentive programs that are tied to energy efficiency. Within the scope of the Savings by Design program, energy modeling is used to compare the proponent's building to a code reference building. So the proponent's building design starting point, where we begin the workshop at the beginning of the day, is usually called the baseline. This baseline is then compared to a reference building. The reference building is essentially the same building as the proponent's building in terms of geometry, occupancy, use, set points, location, and so on. However, it is built to the code minimums of OBC SB 10 or OBC SB 12, depending on if the building is Part 3 or Part 9. During the workshop, a number of energy conservation measures, or ECMs, are put forward by the subject matter experts and then modeled or incorporated into the energy model to see what savings in terms of energy or cost are achieved over the baseline building as well as over the reference building. At the end of the workshop, the goal is to have a final bundle of these energy conservation measures, or ECMs, which achieves the Savings by Design program goal and also achieves the proponent's energy, carbon, and utility goals. When talking about comparing options for decision-making using energy modeling, it allows you to compare various energy conservation measures in terms of their impact on utility costs, energy use, and other metrics as well. For example, in this summary chart, 9 energy conservation measures are being compared in terms of their effect on energy as well as utility costs. And similar comparisons can be also made for other ECMs and other metrics as well. Code compliance is one of the uses of energy modeling, and energy modeling is used to demonstrate that your particular project is compliant with the particular energy code or standard. The 3 relevant ones for buildings in Ontario, specifically in Toronto as well, are the OBC SB 10 and SB 12. So the Ontario Building Code requires that certain energy targets are met for both Part 3 and Part 9 buildings at permit. For both of these buildings, there are prescriptive and performance paths available for demonstrating compliance. The performance path, which is using an energy model, allows more flexibility for the owners and designers of the building. Perhaps some prescriptive requirements are challenging to meet, and that's why the performance path exists. It allows a little bit more flexibility as well as freedom for the building design. The buildings applying for site plan approval in the City of Toronto also require to use an energy model to demonstrate compliance with the City of Toronto's energy targets for total energy use, for greenhouse gas intensity, as well as the thermal energy demand intensity, and that's at site plan. For buildings in Toronto as well, for zoning applications, if the project is over 20,000 square meters, energy modeling is also required in the scope of the energy strategy report. Other municipalities also require energy simulations to demonstrate compliance with their particular standards. York Region, Woodbridge are some of the examples. What are the financial benefits of energy modeling? So we talked about the process of modeling and what we can get out of it, but what are the financial benefits? So starting from the beginning of the design there's tremendous financial benefit in terms of cost avoidance from evaluating design options early on to avoid redesign costs, particularly when there are codes or third-party targets which the project must meet. It is crucial that the design starts off on the right foot. It's not unheard of to have a project which may forego the expense of energy modeling early on, only to realize at, for example, building permit stage, or even later on, that mandatory targets are not being met. So meeting those targets then necessitates design changes, which have an impact, of course, on the project budget as well as the project timelines. Using energy modeling early on can help projects avoid these costly scenarios. Energy modeling can also be used to save money over the operation of the project by helping to find options which have a lower utility cost as well as a lower life cycle cost over the life of the project. And of course, projects can be eligible for incentives, which is a little bonus after having an energy efficient building. So these provide either rebates or direct financial incentives in the form of a check if certain energy targets are demonstrated through modeling. So examples of these incentive programs include, of course, the Enbridge Savings by Design program, the IESO's Energy Performance program, and various municipal rebates, and also rebates and incentives through the CMHC. Okay, so we talked about energy modeling, but let's talk about the Savings by Design energy modeling in particular in terms of what the intent of the modeling and the workshop is. So the model in the workshop is intended to provide you as a proponent with a general impact of each of the ECMs that will be presented by the subject matter experts. It is a general impact. It is not precise. So it is not something that you keep to your utility bills. It will provide guidance to potential energy costs and energy impacts of these ECMs. It will also provide you with one possible pathway for compliance with the Savings by Design target, whether it's the 7% improvement over code for an affordable housing stream, or the 15% improvement over code for the commercial building stream. Since the modeling protocols differ for Savings by Design from the modeling protocols for building permit, or from Green Standard, and for LEED, for example, there are certain things that this model cannot be used for. So for example, it will not provide you the exact performance of each of the energy conservation measures. For example, LEDs, it will not provide you the exact number of kilowatt hours that you will save. It will provide you a general idea. I will not be a guarantee of energy savings, so this is not something that you can guarantee your utility bills to be in line with. It will not provide your design phase Savings by Design submission, as that will be based on your actual permit documentation. It is not the site plan approval model that you can submit to the City of Toronto. It is not the permit model that you can submit to the authority, the permitting authority, and or any other target submission documentation. And it will not address every potential pathway to the Savings by Design target. There are numerous pathways you can take to achieve the same goal, and the model that we will have at the end of the workshop will provide you with one possible way, but you are not tied to it. You can meet those targets with whatever way is most suitable for your particular project.
Okay, thank you, Alexandra, for preparing that for us. Now I'm just checking to see if we had some questions prepared, and it looks like we don't. So would anyone like to jump in with some questions for Alexandra now?
Hi, not hearing anybody else speak, I thought I would take the bait. My name is Greg Redden. I'm a partner and architect at MZE Architects. And in 2005, with the development of the LEED program, I became LEED certified. And in those, 15 years since then, we've had an opportunity to work on 2 LEED projects, the last one 10 years ago. And at that time, early on, many municipalities had proclaimed that they wanted all of their municipal buildings to target a minimum LEED silver. That's all gone away because the cost of that program seemed to have turned people off. So now there are these other programs that Enbridge is offering, CMHC, and we're wondering, when our clients come to us with a CMHC application that requires certain targets, and as architects, we design a building and we specify a building and we stuff it full of insulation and specify the most appropriate windows. It's really, I want you to confirm for us that when we talk to our clients, we can tell them that it's really a design team effort. It's mechanical, it's electrical, it's architectural, all working to achieve this. It's not, it doesn't just come from the architectural end. And when all of the modeling is done, it draws from all of those disciplines, and everyone is contributing to the process. Because we want to make sure that our clients weren't under the impression that it's just how the building looks that determines it, but it's all those systems that working together. So I guess just wanted confirmation that in the building modeling process, all those inputs add up to the performance result. Is that correct?
Absolutely, that is 100% correct. Architecture is a very important part of the whole building. In the modeling, that's certainly reflected, but it is a combination of the mechanical systems, the electrical systems, and the architectural.
Okay, so we've been saying that, you know, when a client presents us with CMHC requirements, yes, they're all achievable, but we can't prove that until the building is designed and on all systems designed, and then the model is complete. And then the model will tell us if we fell short, which will indicate where we need to bulk up something, either lower energy use or more insulation. And then we can actually use the model as a tool to manipulate the building so that the results are getting at least our minimum requirements.
Absolutely.
Okay.
And you can make those decisions, you know, you can make the changes that accommodate your budget, and it can be a trade-off between mechanical and insulation and so on.
Okay, thank you.
Hi, Alexandra, Larry here. Wondering if you could maybe speak a little bit to some of the exemptions within the code that contribute to the performance gap between early design stage modeling and end use building.
Absolutely. And those exemptions vary greatly depending on what protocol you're modeling to. So as I mentioned in the presentation, there's the LEED protocols, there's the protocols we use for savings by design, for permit, for Toronto Green Standard. And typically, you will have a lot of variation between the results you get from there and actual operation, and those stem from simple things such as the fact that we're allowed to exclude certain thermal bridges, for example, under certain programs. So they don't represent a true value, for example, of your wall. There's, of course, schedule differences. So for example, for Toronto Green Standard for LEED, we're mandated to use certain schedules for building use or lighting, occupancy, HVAC, and so on. Those schedules may be different from what is actually happening in the building. There's occupant control, of course, and I think that is most prevalent, or the difference is most prevalent in residential buildings where the occupants have direct control of the temperature set points within their suites. And those can vary from what has been modeled. And there's differences that result from construction as well. So you may have something on your drawings and specifications that doesn't necessarily get built. An example of that is infiltration. Infiltration is a very key factor in the building heat load. And that greatly depends on the quality of construction that you have on site. And there's only so much you can do at design, but that is a big factor. Weather as well. We model with typical weather files, and those are current for right now, but they may not be reflective of next year's weather, or even weather in 10 years from now, where you'll have even bigger differences from today. I think that covers a lot of factors, Larry.
Yeah, that's it.
That was good. Alexandra, I was going to ask specifically about the climate files, if you could expand on that a little.
Yes, so for modeling, we use typical weather years, and what that means, it's a collection of data that they take, for example, for 10 to 30 years, and then they develop a year that represents the average of those. So it's not, for example, the 2016 weather year that you're using in the model. It's sort of the average. And as we know, the averages have been changing more rapidly as time goes on. So we use the 2016 files released by, I think it's Environment Canada, in our modeling. We also use future weather files, which represent the weather which as is predicted in 2040 to 2050. And those weather files have a significant higher average outdoor temperature and a significantly lower number of heating degree days and significantly higher of cooling degree days. So when we analyze that, it's really interesting to see the impact on the energy use in the building, but also occupant comfort, which is greatly affected by the outdoor air conditions, especially in the cooling season.
Thank you.
Mary, you've done a number of our projects through Savings by Design. What would you say would be some of the challenges that a lot of the developers, builders are facing right now with energy conservation measures?
I think it's, as the energy targets have been changing, as they have been, I would say more rapidly. Our Ontario Building Code has evolved since the OBCSB time came into effect, and it's getting more and more stringent. And some particular municipalities like Toronto, Woodbridge, and York have even higher standards for energy. So that has been a challenge, particularly from sort of the architectural side, where we've seen a number of buildings that have a higher window to wall ratio, for example, a lot of balconies, which introduce a lot of thermal bridges into the building envelope. That has been a little bit challenging. Other than that, I would say it's sort of a challenge and an opportunity at the same time. If you go into the workshop and you're not really sure what system and what design you're going forward with. So it's a challenge from the modeling side, where we're trying to figure out what your building will be like, but it's also an opportunity because there's a lot of room for change. Decisions haven't been made, and you can use the modeling to make those informed decisions to meet your energy targets or whatever utility targets or carbon targets that you may have.
Great, thanks. Just one last question. Knowing what we're all going through right now with COVID, filtration seems to be the #1 topic, indoor air quality, filtration. How do you see that changing with the modeling? Because it's going to be, I would guess, an added load a lot more than what's maybe perhaps being measured today.
Yep, absolutely. So we do get to sort of take credit. You're being modeled against the building that is operating substantially the same as your building. So if you have added filtration requirements, that will affect the fan power in your building, but as well as the reference building. So you will be compared to a building which has the same filtration, sort of static pressures that you will have. This has already been happening, for example, if we've had a hospital project where those filtration requirements have always been extremely high and resulted in higher static pressures for the fans to overcome. So that's reflected in the reference building as well. On the overall energy picture, I can see fan energy and maybe even ventilation energy if you're looking to minimize sort of mixed air in the building. So those energy uses would increase with sort of this pandemic in mind.
Do we have any other questions from the audience?
Yeah, I have one.
Go ahead.
Okay, can you hear me, Harold Ensler?
Yep.
Yeah, I'm following a number of articles I've seen in the paper recently about passive house design, and the images that I see of those buildings are a little concerning to me as an architect. I'm always thinking of kind of what's it like to live in this place. You know, what kind of windows, what kind of balconies, the quality of life. And I see these projects are very tight rectangular boxes without any indentations, without any profile or shape, with with benefit to smaller and smaller windows. So I guess there's, from an architect's perspective, there's a fine balancing act between the quality of the building you're designing and the energy requirements, and the two seem to be at kind of opposite ends. So Alexander Park in Toronto is an example. That was in the Globe and Mail recently, which is, my humble opinion, a pretty nasty looking building. And I see there's also one in Hamilton, Parkdale Landing, which is also a very tight rectangular box. So I'm hopeful that through clever design, we can meet both objectives, but it will certainly be a challenge.
Yes, that is, I would say, the correct observation. It would be a challenge. It is, if you have a sort of a less articulated building, basically a rectangular box with smaller windows, it is certainly easier to achieve those passive house targets. A lot of them are, they're all central on minimizing the load to the building. So the less articulation you have, the less opportunity for thermal bridges, the smaller the windows, again, the less the heat load from those sources. However, there is opportunity to have a more articulated building with a little bit more windows, but those details generally are costlier. So you're looking at thermally broken Z-girts, you're looking at triple glazed windows, thermally broken balconies. So it is achievable, but those details will be more expensive.
Yeah, I just want to make sure we don't lose that part of the quality of the buildings we design. So that's a concern for me. Thank you.
Yeah, absolutely.
Thanks, Harold. Do we have any other questions? If not, I have one that's maybe stepping back a little bit, but as a builder brings a project to you, what do they need to bring to you, and sort of what stage can they go to an energy modeler and start this process?
So we usually say the earlier the better. You do have to have substantially set, not complete architectural drawings, but set. So you're not changing, areas, the building footprint is sort of defined. That is the ideal stage. You have an idea of where your window to wall ratios are. And if you don't, the energy modeling is a great tool to figure that out. So that's in terms of architectural, that's the sort of the sweet spot of where we like to get to a project. In terms of mechanical and electrical, if schematic design has started, that's a good opportunity as well. Generally, it's best if we get involved before a system is finalized, just so we can take a look at a few different systems, and then the proponent can see the impact of those different systems and still have the ability to make the decision which way to go. But to be honest, we've been involved in projects where they're perhaps closer to permit submission. They may have a system that they've selected. They're just looking to fine tune a few things, play around with efficiencies, the control strategies. They can still change the lighting, look at the different levels of insulation in the walls and so on. But the earlier, the better.
I think earlier the better is great advice for all design projects.
Yes. Not always realistic, but you gotta say it.
Okay, do we have any other questions from the audience?
Hi. Hi, my name is Rida. I'm a project manager in the construction industry. And I do have a question about the choice between wood versus concrete construction. Is there a preference regarding this materials? And also, is there a way to consider the embodied energy with in the design? So that's my question.
So in terms of preference, wood over concrete, it's difficult to make a sort of general statement. All of those options are better than steel frame construction, so I'll just say that. Steel frame construction has a lot of thermal bridges that happen in the building envelope. Wood is a better product for limiting that. It all depends on the amount of insulation that you can fit into the building. So if you can fit in more insulation in your wood construction as opposed to your thick concrete wall, great, then that's the way to go. But it really depends on how you're designing that assembly in terms of where the insulation is going and how thick that insulation is. And in terms of embodied carbon, of course, wood is preferential in terms of that. Under this program, we do not consider embodied carbon. It is considered under the Zero Carbon Building Standard, where we do embodied carbon calculation or life cycle assessment on the project, and it is considered in that program, but not here.
Alexandra, is there a way for you to for the energy modeling process to account for embodied energy, or is that handled separately?
There is some synergy with the software that we use to provide that. To be honest, I haven't used that capability. Usually it's a separate calculation. I know for the ISO carbon calculations, they are sort of limited to what you can use for that. Yeah.
Okay, thank you. All right, do we have any other questions from the audience? Okay, well, I have one more question for you about energy modeling types. I know that there are a great number of energy modeling softwares at this point. Are there any particular constraints of the different modeling softwares, and which do you prefer?
So yes, each software has its own constraints, mainly sort of like how much changes can you make after you set up your model. For example, eQuest, it's challenging to change geometry after that's set up. So generally you want to start the modeling process when your architecture is more finalized. Other softwares allow a little bit more flexibility in that aspect. We use IES Virtual Environment as well as eQuest occasionally, but there's a number of softwares that are both approved for savings by design and for LEED and for code compliance out there. So there's a few choices.
Okay, thank you. And we actually have maybe a question from Mary about opportunities to enroll in the Savings by Design program for this year.
Sure.
Is there still space available?
Yes, we still have space available. As you know, that last year we amalgamated with Union Gas. So this program now is being offered right across Ontario for the commercial savings by design. So yes, there is room available. We also have a stream, which is the affordable housing. And because we're still working with two different frameworks, the legacy Enbridge on affordable housing is at capacity right now. So they're taking applications for next year. Now saying that, they can take the application, we can actually do a workshop towards Q4. and then that would be considered 2021. However, if you have any affordable housing or any projects in what we refer to as Legacy Union area, we're still taking applications. So if you have any questions on that, please do reach out to me, and I'd be more than happy to guide you or take your application.
Great. Thank you, Mary.
Thanks.
Okay, one more opportunity for any other questions from the audience. Okay.
Before we sign off, Adam,
Sure.
sorry, if anyone has any other topics they'd like to see in the webinar, please do reach out to us. As I said earlier, this is our first webinar, and I appreciate everybody joining us. But if there's a topic or a technology you want to discuss further, please reach out. We'd be more than happy to accommodate.
Thank you for that note. We're going to send out a short survey after this with precisely that question. We're quite open to feedback, and anything that is of particular interest, we're happy to hear about it and put something together. So I think with that, if anyone has any questions, jump in now and interrupt me. But with that, we will wrap up our session today. And our thanks to Alexandra and to Mary and Enbridge, of course. And thank you all for joining us today. And we hope to see you at the next one. Thanks a lot. Bye, everyone.
Thank you.